And we are also going to see about how machine learning works, few of the machine learning algorithms, use cases, and also on how to use quite a few machine learning frameworks. So to start with, we need to understand what is a learning. Learning, as we all know, is a process by which system improves performance. And it applies to say any kind of systems. Ideally, a system which is being developed and get enhanced over a period of time, wherein as a system gets used over a period of time, we keep enhancing it in the form of changing the system over a period of time, making it a better system. So learning is a process in which system improves performance. The process of automating the learning into a system is what is called as machine learning. Next, we are going to see about what is meant by machine learning, what actually drives organizations to adopt to machine learning. Ideal, say, business differentiators, which or help businesses or in to adopt to machine learning, or the analytics space, customer engagement, and say any say a place where the organization wants to drive efficiencies in the system in terms of efficiencies in the way the data gets processed within the system, or efficiencies in the way the system say performs, or efficiency in the way an system gets customized. A few of the scenarios where machine learning can be ideally used, or places where there is no human expertise that is required, that is available. A black box scenario where human expertise is very limited, or any place where say we want to rapidly capture the rapidly changing data, and also for personalization based on the inputs received by a system. Okay, so let's move on to how machine learning works. Machine learning works based on a predefined set of goals. So which means that which means that I have a predefined set of goals which needs to be accomplished, and these goals say can be in the form of data received from multiple streams in a system which needs to be analyzed to achieve a specific goal, or it can be analysis of a specific set of patterns within a system which can be analyzed. So the entire the entire model with which machine learning works revolves around analyzing the data real time, and then taking a decisions on based on the data. So this is going to be very critical, as based on the data we can take a lot of say hypothetical decisions. We can also say redefine the model with which systems work altogether. There are a few say standard algorithms which are primarily used in machine learning. One is and they are categorized based on the usage with which a specific say organization requires it. Most predominant say algorithms are supervised algorithms, unsupervised algorithms, and semi-supervised learning algorithms, which means that say I adhere to a process where I supervise a system or a set of models within a system, get the required data elements. Based on the data elements, I make the system work more efficiently. So let's get into something on supervised learning. Supervised learning is something like say predictive kind of outcome. Let's assume a case where we already know outcome of the task that is getting executed or a list of tasks that is getting executed. When we are very sure that these are the list of tasks that needs to get executed, this is the outcome of each of these tasks. That is where we can go ahead and implement a supervised learning algorithm. This is ideally suited in cases where we get data from multiple sources, and we want to analyze data and then check if a specific say behavior or a pattern is exhibited by the data. So such cases are use cases of supervised learning. So in this specific supervised learning model, there are a lot of combinations in which supervised learning can work, and it is best suited for places where we know the outcome of what we want to achieve. So let's also check something on unsupervised learning. So unsupervised learning is something like I know the behavior of a system, but I am not able to predict the inputs or the outputs. Say in such a case, I can use an unsupervised learning algorithm. Typical scenarios can be somewhere on the data center. If I want to receive the data such as health parameters of a system, and based on the health parameters, I want to take a few actions, or I want to let's say get data from a device and then store it over a period of time, and based on the scenarios I want to check the outcome. So these are the few places where unsupervised learning can be really be useful. Semi-supervised learning is ideally a combination of supervised and unsupervised learning, wherein a mixture of say data elements which have predicted behavior, unpredicted behavior needs to be say profiled and predicted. This is very rare. Most predominantly supervised learning is a learning algorithm which is predominantly used. So when we talk about any of these algorithms, we should also know the use cases associated with machine learning. Primary use cases of machine learning is in the customer engagement segment or customer engagement area, where every business wants to engage say customers interactively, real time, and based on the interaction, get the data. So do a modeling, predictive modeling using say supervised learning, and then say generate recommendations based on which they can improvise the customer engagement. So these are ideal scenarios where machine learning can be really helpful, where every business or every organization can improvise on the customer engagement. There are also a few other use cases where machine learning finds interesting say usage, where typical scenarios are chatbots, which are predominantly used in banking and insurance sector. Ideal use cases are customer servicing chatbots which sell products, which also cater to a lot of questions raised by customers when they interact with the chatbots. So primarily a query driven, it can be a query, so it can be IVR or a say or a call center based chatbot which interact with the customer, gets the queries and then responds back to the customer on the queries. It can be a chatbot which gives details of the product to a customer. This is predominantly one of the emerging areas in machine learning, especially using a chatbot. A few other areas where say machine learning gets improvised, say use case is on the security, where customers want to monitor their systems automatically, get the security parameters that are modeled and analyze the security behavior of the system real time. This is also one area where machine learning can be predominantly be used. Most challenging area where machine learning can be used is on detecting frauds, especially like in cases where a bank or insurance sector wants to detect frauds real time, and by learning about the existing frauds that has already occurred, and also getting data from the public domain and then applying say learning algorithm, fraud detection mechanism can be improved real time. So these are the few use cases where machine learning can be really be helpful. Um, so we discuss a lot about machine learning, the algorithms used, use cases. The next comes how do we implement it. So yeah, there are a few ways in which you can implement machine learning. One way is you can use generic frameworks like Spark, MLib, MLPack, Accord, Net Framework, and Vika. These are primarily frameworks which focuses on building a generic machine learning. Additionally, we also have frameworks which are available on the cloud, like Amazon Machine Learning, Cloud Machine Learning, Google Cloud Machine Learning, Azure ML Studio, and Nirvana Cloud Platform for Deep Learning. There is a difference between how the generic machine learning differs from deep, other say learning algorithms. One of the most primitive say ways in which they differ is the extent to which we analyze and profile the data differentiates how machine learning works. Few of these frameworks which get into detailed level of machine learning are TensorFlow, MXNet, Caffe, CNTX, and Nirvana Neon frameworks. So these frameworks help us to do a deep learning where I get a machine learning model created, analyze it, take a decision on it, and based on the decision again I can say get a predictive model generated and analyzed further so that I can get multiple outcomes. And when it comes to implementation of machine learning, there are two ways to implement it. One is one way is implementing machine learning real time, and another way is implementing machine learning for data at rest. So either of these cases, a combination of these frameworks can be used. Okay. So final to close the session, we can probably have a overview. Machine learning is a kind of model where system learns by itself and then takes corrective action. So predominantly in use cases where we need to collect data on the systems or application behavior, and then make the systems more intelligent. This is where machine learning can be ideally used, and it in this aspect it differs significantly from AI, and it also derives significant say benefits to all the customers who initiate machine learning in their enterprise and then implement it.